All right, so here are some examples about experimental design. So we are going to write what kind of experimental design it is, and then do the little flow chart that describes the experiment, and then any kind of blocking or matched pair. We'll talk about that. So types of experimental design. Are completely randomized. That's when you're not worried about any confounding variables. Another one would be the randomized block. That's when you have two different sets of groups. Like you could do it by age, by gender, by grade level. You could block it any way you need in order to get rid of some confounding variables. And then the next one would be matched pair. So whenever you want to look at similar things going on, so it'll limit some confounding variables between differences of people or subjects. So an example would be with weatherproofing boots. You could have a person have a weatherproof boot and then a non-weatherproof boot, and then wear it for 3 months and see the difference. So that would be matched pair, because you have your left foot and your right foot. They're going through two different treatments. The treatments is the weatherproofing, and then you look at the results of how the boots held up. Okay, so we'll look at number 1. A baby food producer claims that her product is superior to that of her leading competitor in that babies gain weight faster with her product. As an experiment, 30 healthy babies are randomly selected. For 2 months, 15 are fed her product, and 15 are fed the competitor's product. Each baby's weight gain in ounces was recorded. So, what kind of design would this be? Is there anything that it tells us we need to block for or control? It doesn't say. It doesn't say anything about the initial baby's weight could impact. It doesn't say that. If it doesn't say anything can impact the results, then we're not going to block. So we are just doing a completely randomized. Completely randomized design. Okay, so we start out with our experimental units, which are our subjects. So we have 30 babies. What do we do with those 30 babies? Randomly assign. It doesn't ask us how we're randomly assigning, so we can just leave it like that. If it said elaborate on how you will randomly assign, you would list out all the steps. So we're going to assign it to how many groups, how many treatments do we have? We have 2, yep. So group 1, and we have group 2. And we cut it in half, so 15 in each group. We evenly divide it. One group is going to get her food for 6 months. So whoever she is, she says that her food is better. Her food is fed to the baby for 6 months. And then the competitors, food for 6 months. And after the 6 months, what do we need to do?
Compare.
What are we comparing?
Median.
Yeah. Okay, so let's identify different things about this. All right, so we have, it's a completely randomized design. We have the experimental units, which are our subjects. And then we have, let me look at something real quick. We have the factors, would be the two types of food. Factors, so it'd be type of food. And then levels, we have two. We have her food and competitor food. And that's also our treatments. So treatment 1 is her food, and the competitor's food is treatment 2. If we had a mixture of multiple variables, we'd have to deal with that, but this one just has 2. And this, the food, these are the explanatory variables. Type of food. It's her food or the competitor's food. And then our weight gain is our response variable.
I got a question.
Yes.
I'm confused on how to decide if it's randomized or completely randomized block, or matched pair.
So to know whether it's blocked or not, you would look for anything within that population. Like if they specify something within that population that could affect the results, we would do blocked. In this one, they didn't say anything will affect the results, so we're going completely randomized. Matched pair would be if you're testing out, you'll see it in a second, because
Okay.
each one of these, we have blocked and we have matched pair. So you'll kind of see the difference.
It's like two different things, but you do the same thing with both groups, and you just see the different results.
Yeah, and it could also deal with like the order that you do the 2 treatments. So we're not doing the order of the 2 treatments. We're just doing one group's going to get her food, one group's going to get the others. So you'd look for like a detail in that paragraph that says this could affect the results. Then that'd be like, oh, I got to do blocked. That would be like your key phrase that you're looking for. Okay, so I think we're good on that. Let's go to number 2. You're participating in the design of a medical experiment to investigate whether a calcium supplement in the diet will reduce the blood pressure of middle-aged men. Preliminary work suggests that calcium may be effective and that the effect may be greater for African American men than white men. Outline the design of an appropriate experiment. So, do we see a key phrase in there that says you need a block because this could affect the results?
Maybe greater for.
Yeah. That tells me it needs to be blocked. Hey, pay attention, guys. This right here says we need to block. So we are going to block it by race. Because we want to compare all the African American together and then all the white together. And then you can compare them overall and see if that's really the case. So we are going to take our middle-aged men. We weren't told how many, so I'm just going to put middle-aged men. If it tells you how many, make sure to include that. If it doesn't, then you can either give it a number and split it, or you can not give it a number. And before we even randomize, we need to block by race. So we would split it up. African American men, white men. So you do that before you randomly assign. And it's wanting to test out a calcium supplement and see if it will reduce blood pressure. So we need to give each, so we'll say group 1. Oh, yeah. Thank you. Good catch. Yeah, we need to randomly assign. So, randomly assign. We want to randomly assign them to the 2 groups. Group 1 is going to get calcium. What should group 2 get?
No.
They need to get something because we're comparing.
Oh, placebo.
Yeah, placebo. 'Cause remember, just the thought of it might reduce their blood pressure. Okay, and then we'll do another group. Group 3 is going to get calcium. And group 4 is going to get the placebo. And we would want to blind this. So you can do blind or double blind. Remember, blind tells, or the patient will not know what they're getting. That way the thought will not change their blood pressure, because that can happen. So it is a blind experiment.
We have to write that down.
If it asks for it. I don't think we've really ever written that down. I think just having that word placebo indicates that we're going to blind it. But if it was a multiple choice question, you would make sure to answer with blinding. All right, so then you would compare. What are we comparing?
Blood pressure.
Right, blood pressure, BP. So you compare it within each block. And then compare overall. All right, number 3. Is the right hand of right-handed people generally stronger than the left? Some guy designs an experiment to test this question. He fastens an ordinary bathroom scale to the shelf 5 feet from the floor, with the ends of the scale projecting out from the shelf. Subjects squeeze the scale between their thumb and their fingers on top. The scale reading in pounds measures hand strength. Interesting. So, what would we want to do on this? We want to see if the right hand's stronger than the left in right hand people. How should we design our experiment? Yeah, it should be matched pair. Because what if somebody's just generally stronger? Are they going to be able to squeeze it, better than someone else? So you want to be able to compare one person's left hand with their right hand. And that's how you get that matched pair. So we would do our however many people. We're going to start out with right-handed people. And we're going to do some random assignment. The order in which you squeeze it could also affect. So a person who squeezes it their right hand first and then their left, that could affect the results. So when we do match pair, we're going to do, one group is going to do right then left, the other one's going to do left then right. So that we can see if there's any confounding variables with the order that you squeeze it. So we're going to randomly assign them to two groups. So let's do group 1 and group 2. So group 1 is going to do treatment 1, which is squeeze their left hand first. So if it says it's treatment, it's just squeezing the scale. And then they'll do the right hand. And group 2 will do the opposite. Right hand, which is our treatment 2, goes first. And then what are we going to compare? Yeah, compare hand strength, which is our scale differences. And our hand strength is measured by scale differences.